Class, and welcome to another video. Today's lesson is on distributive property. Here's the first slide. Distributive what? So have you ever passed something out like papers, cake, or video games? So another way to say that is you distributed that item. So the distributive property works the same way. In the front, or the variable, is distributing themselves across the other numbers or variables in the parentheses. So this is very important to know, in the parentheses. Okay? And we're going to see that in the next slide. So here we go. So technically speaking, the distributive property, please write this down, pause the video and write this down. The distributive property is a rule that allows us to rewrite very specific expressions so that the parentheses go away. But the value of the expression does not change. So think of it as going to a party and saying hi to each friend. So for any number A, B, and C, here's how it works. So if we have A here and we have parentheses right next to it, there's no sign or anything, and then there's B plus C, whatever is in the parentheses, then we close the parentheses. What this means is that we are distributing this A within each term in the parentheses. So it's like saying A times B plus A times C, because we're just distributing it. And so parentheses, every time you see parentheses with no sign, like no operation sign, like a plus or minus sign, this means to multiply. Parentheses, please write this down. Parentheses means to multiply. Okay? And here we go. Let's look at the next slide. So here's an easy problem. Just like the problem before, if we can solve this two ways. So if you have parentheses, just like in PEMDAS, you should solve what's in the parentheses first. That's what they say. So we can see that 2 plus 3 equals 5. So we can do that, and then we know that that equals 25, right? If we distributed this 5 into the terms in the parentheses, then that is also equal to 5 times 2, which is 10, plus 5 times 3, which is 15, and that also equals 10 plus 15 is 25. So either way you do it, when you're solving using distributive property, you should get the same solution. All right, let's try the next slide. Okay, so like I said in the last slide, if you have 5 times 2, if you use the distributive property, right, because parentheses means to multiply. So if you do 5 times 2, that equals 10. Bring down our sign. 5 times 3 is 15. So you get the same thing. Okay, so either way you do it, if you want to solve what's in the parentheses first and then multiply, you can do 5 times 2 plus 3, which is 5. So you have 5 times 5, which is also 25. You get the same thing both ways. Okay, let's try the next slide. Here's the first problem. Please pause the video and write this down. So if we are simplifying this algebraic expression, remember simplify means to make it smaller. So we are reducing the number of terms by simplifying. So we're going to multiply this 6 into all these terms within the parentheses. And this arrow is just to show you. You don't need to draw that in your notebook, but you can if you need it. We have 6 times 7, A, and so when we multiply these, we're just multiplying the numbers. So 6 times 7 is 42. We leave the A. Plus, because there's a plus sign. 6 times B, we can just write that as 6B. And then we have a minus sign. When we do our last term, 6 times 3, we leave our minus sign there. 6 times 3 is 18. All right? And that's all we need to do for distributive property. Let's try the next slide. A rectangular garden has a length of 8 feet and a width of 9x plus 3 feet. So let's draw this first. And please make sure you're drawing this in your notebook. So if one side is 8 feet and the other side is 9x plus 3 feet, what is the area of the garden in terms of x? Well, we know to find area we need to multiply. So we can say 8 times plus 3. Oh, and we can use the distributive property here, right? So 8 times 9 is 72x, because we have to remember our variable, plus 8 times 3, which is 24. And so the area of this garden in terms of x is 72x plus 24. If you need to pause and re-watch this video, please make sure you do. Here's the next problem. Here's problem number 3. Indicate whether each expression is equivalent to the expression 30x plus 20 by checking the appropriate box in the table below. So is this equivalent to 30x plus 20? And I'm going to write it right here. You should copy this into your notebook. So are these equivalent? No, they are not equivalent. So the 30 is not the same as the 20. 20x is not the same as 30x. So they are not equivalent. Are these equivalent? Well, we know that 5 times 6 is 30. We bring our variable over also, so this is 30x. 5 times 4 is 20. So these actually are equivalent. Okay, let's look at this next one. 10 times 3x, that gets us 30x. And 10 times 2, that gives us 20. So yes, that is also equivalent. All right, so this is how we tell if things are equivalent, if expressions are equivalent. Okay. And here we go. Here's your homework for tonight. Please make sure you complete all of them, and I will see you tomorrow.